give it back to you, Matt.
Sure. Yeah. So I'm Matt Koterbinski. I am starting year 3 here at NREL. I work in the hybrids group, and this is my first IEA task. So I'm happy to be here. David?
Hello. First of all, I just wanted to wish those of you who celebrate Diwali a very joyous Diwali. We realized that we had planned the meeting right during the festival, and we apologize for that. And we're just glad that it was not scheduled for yesterday, which of course would not have ultimately worked. So my name is David Dunn. I work at NREL in Colorado in the United States, and I am trying to support Kaushik and Jen and Matt with project management work, as well as trying to figure out how Teams does recording.
Chris?
Hi, everyone. I'm Chris Fay. I'm a research engineer at NREL as well. Been there about 4.5 years, focusing controls and optimization, particularly in wind energy, but also more recently in hybrids. So excited to be here.
And Dan?
Yeah, hi everyone. I'm Dan Hauk. I'm a researcher at Sandia National Labs in New Mexico, Albuquerque, where it's quite early. And I haven't actually worked on hybrids before. I focus on wind energy, fluid dynamics. So this is going to be a learning experience for me, also my first IEA test. But over the next 3 years, I'm the Sandia lead for a project that Jen is leading at NREL that will be working on hybrid power plants in the US. Thanks.
Awesome. Thank you. Okay, so first, I just wanted to talk about why it is that we're here. And of course, hybrids are highly complex systems that are customized kind of based on site and application-specific end uses. And of course, the challenge is with this complexity, there is no clear definition or taxonomy as to what a hybrid plant currently is, and everyone seems to define hybrids differently. And terminology is also not used consistently across all the various sectors, whether that's within research or within the industrial communities. And so it's always unclear what needs to be considered. And so, for example, we have to ask ourselves, what technologies do we want to focus on, definitions, and scaling, for example. And so the goal of this workshop, so for work package 1, is to identify language and define what a hybrid plant is, and to ensure that we're coordinating this preferred language to develop consistent terms within the research field. Because if we can't do that, then it's a lot challenging to help reduce deployment barriers for the acceleration of hybrid power plants if we can't necessarily seem to define them consistently. And so the workshop of this goal is, the goal of this workshop is twofold, and that is to develop hybrid power plant terminology and to also establish a global understanding consistently of what hybrids are. I wanted to bring up a couple different perspectives for hybrids and how everyone defines them. So for example, Wind Europe, based on their website, they have 4 different components for a hybrid power plant. So that includes wind, solar, storage, as well as co-location. And as Wind Europe defines hybrids, it's a power generating facility that converts primary energy into electrical energy, which consists of more than one power generating module connected to a network at one connection point. For some more contrast and perspective, ESIG defines hybrids as a combination of multiple technologies that are physically and electronically controlled by the plant's owner and participating as a single resource. And so those are 2. And then I wanted to loop in Kaushik and Jen to help give a perspective from DTU and NREL. So Kaushik, if you wouldn't mind going first.
Is it okay? I quickly share my screen.
Sure, absolutely.
Yeah. So what I can make it full screen here. Yeah. What I wanted to talk about again, like this hybrid systems has been so much used intentionally, unintentionally in literature and beyond, that there is no clear consensus. And that's what you were also showing here, Matt, that already there are a couple of definitions and we did not bring in the microgrid aspects and things like that. But I would also like to say, I was just checking if Ian Baring Gould was joining, but together with Ian and others, we are also having another task, IEA task 41, where we are looking very much on the microgrid aspects as well as the smaller scale hybrid systems. So that's why I tried to focus, even though we are working on all the aspects at DTU, I tried to focus for the task here on utility scale co-located and grid connected. And the grid connected is the last keyword here, because it can be grid connected or it can be off grid for hydrogen production or something like that. But the main interesting point which we have been discussing in the task until now with between Jen and us, NREL and DTU, is that we have the wind and the solar and battery or any other storage, and what are the components. This is also a topic to discuss today in the breakout rooms, as I believe, Matt. So this nothing is defined, but this is just framing a starting point for the dialogue, that then they share a single grid connection. And then the most important point, and I should thank our PhD student Sohail for making some slides for me, is that if it is utility scale hybrid plant, then it is generally typically connected at the transmission systems. And then the stakeholders are the independent power producers or the developers, be it we are seeing more coming from the wind side, but also solar developers and hybridizing them. But also in the microgrid, it's on the distribution level, distribution network, and then the microgrid customers and the owners are more on focus, which is more of a hybrid system instead of a plant. So the major difference, as I see it, is that when you develop a hybrid power plant utility scale, the design is for maximizing the value for owner. And in that way, it might sound a bit harsh to maximize the value for the developer or the owner. But in that way, we can reduce the cost of technology or cost of hybrid, and helping the society in larger goal of reducing the electricity prices or energy prices for that matter. Whereas the microgrid, it is more about the security of supply of the loads and reliability of the loads, which is of main concern, and not the maximizing the profit for the owner. And then since the scales are different, again going back, the grid compliance and the requirements are also different. In ancillary service provisions, for example, providing black start capability or the fast frequency response and things like that are of much more valuable for the hybrid plants, which are of large scale, because they can really impact the system. Whereas the microgrids, again, they are small. It can be in an island. It might be valuable to also provide some ancillary services. In that way, it is similar, but still, I would say the how you control and how you design the systems, be it hybrid or microgrid, is quite different because of the scale and the operational principles. Yeah, I would not go through these definitions, Matt, but we can take the discussions again later on this. I hope this was helpful for starting of the discussion.
Absolutely, yeah. Thank you for that, Kaushik. And now I'll pass the torch off to Jen to give Hybrid's NREL perspective here.
Thanks, Matt. My slides here quick. Oops. about that. Okay, so just a few more notes on hybrids from what Kaushik and Matt have already said. I just want to remind everyone, or at least this is our stance for why we do hybrids here. Hybrids can alleviate congestion on the transmission system by producing power closer to the source. And you can maximize the use of existing transmission. This also allows for off-grid solutions for major industrial processes at the gigawatt scale. Kaushik mentioned that as well for things like hydrogen production. And really what I like the way that Kaushik put it, like maximizing the value for the owner. In a lot of ways, it's maximizing the operating hours. It really matters when and where electrons are put on the grid. Some of the requirements in my mind, totally open for debate, is that they are co-located, or at least I think that's what we should pursue in this task. We often talk a lot about two generation technologies, but then that excludes wind and storage and PV plus storage. I'm curious if the group here thinks that's the way we should put it. So I put here two cross-sector technologies paired together. So that could be wind and storage or wind and solar, for example. Hybrids, because they're co-located, we can take advantage of redundancies and interactions to cut costs, like sharing power electronics controls, balance the system. And in a few minutes, I'd invite Seamus to also talk a little bit about that as well. This is not limited to electricity generation, so hydrogen production is on the table, and this is at the transmission level. So really echoing what Kaushik said with a few different twists to it. So some questions that have come up in the hybrid space really are like, can we directly couple systems to reduce redundancies and cut costs? And are there levels of coordinated controls that are needed? So some examples of hybrid systems that we work on are things like adding solar to existing onshore wind, offshore wind plus storage, and wind solar storage. So again, that wind storage is coming in, but then we also look at the combination of generation technologies. And I just want to make sure everyone is thinking, more than just electricity production. We're talking about it really matters when and where these electrons are put on the grid. So electrons that get put on the grid may look like baseload power, or it could be more like a peaker plant, like natural gas, or be providing grid services. And hybrids don't only mean electricity. This can be a really good way to avoid stranded assets, again, to maximize that value for the individual owner. So we're talking about electricity, hydrogen, and potentially other value streams, even carbon capture, desalinization. But the tagline here is the cheaper we make these systems, the faster that these other markets besides electricity are unlocked. So the first session that Matt's organized will be focused on what is a hybrid, and then the second one is focused on what technologies we should bring into the fold and things like that. So I've just put a few here that we've been considering on the storage side. Are there combinations of storage across timescales and across different mediums, basically? So like electricity versus H2 storage or other fuels, and degradation is a huge piece of this. Fixed versus floating systems, and then pipeline versus HVDC. So with that, I would also like to invite Seamus Garvey to give a little bit of his perspective from an energy storage perspective. Seamus, do you mind?
Thanks very much indeed, Jen. My name is Seamus Garvey. I'm a professor of mechanical engineering at University of Nottingham. My main driving force is what I call medium duration energy storage, but I'll explain to you why that's relevant. Medium duration energy storage is storage that's aimed at the kinds of timescales that are actually ideally suited to incorporating wind power into systems. So they're typically with discharge times in the range of 4 hours to, well, possibly 200 hours, but who knows what the upper limit is, 100 or 200 hours. And I had just really one point that I wanted to make within this context. Sorry, I should say I'm responsible for introducing a different new task into the IEA technology collaboration program, but it's not within wind, it's within energy storage. And that new task is all about medium duration energy storage. Because it's been much neglected, you know, there's huge amounts of attention on battery storage, quite rightly, huge amounts of attention on hydrogen, quite rightly, but battery storage is ideally suited for less than 4 hours. Hydrogen is ideally suited for longer than 200 hours. And in the middle, you have most of the requirements introduced by wind. So the one point that I really did want to make in this context is about more than co-location. So the word co-location has been used by every single person who's talked about hybrids as a definition, more or less a key part of the definition of a hybrid plant. And we're sitting within the technology collaboration program for wind. And I want to encourage us also to think about integration, not just co-location. And by integration, I mean that the wind turbine, the definition of a wind turbine, changes from an object that makes electricity when the wind blows to being an object that gathers energy when the wind blows and makes electricity when we require electricity. And if that's ever practical, and I believe it's very practical actually, whatever technology is used in there will be a medium duration energy storage technology, and it will be largely mechanical or thermomechanical technologies. So Jen, can I share one slide and just talk through that for a couple of seconds? It's a window. That one. So this is a slide that I've used in explaining this concept in several different forums. As far as I can see, there are 4 distinct ways in which you can make this direct integration of storage with wind power. I'll take them from the most obvious, but not necessarily the most meritorious. You could use wind turbines directly to raise water, and that has been proposed. And there's an article by DNV actually in IEEE Spectrum in 2017 that alludes to that. You can, of course, use wind turbines to compress air directly. There's some interesting challenges around that, but it is at least theoretically possible. You can use wind turbines to heat up a fluid. And when you first see this, it seems crazy. But when you look into it a bit more, it's not so crazy, because the temperatures at which you're adding the heat are already fairly high. So you do end up getting a reasonable fraction of the mechanical work that went in to heating up the fluid back out again. Or you can potentially use wind turbine work to pump heat. And I'm not going to work my way around this diagram because it's quite complicated, but it is possible to have a system with 2 stores in it. One's a store of coldness and one's a store of hotness. And when the wind turbine has excess mechanical power available, you can pump heat from the cold to the hot. And in the converse situation, you can let it back down again. So all I really wanted to say is these are possible. I believe that they should be part of the discussion about hybrid power plant. I believe that the issue of timescales is particularly important here, because the storage that is most commonly known about, batteries and hydrogen, doesn't fit the timescales of wind particularly well. And I think that there's a separate issue about the wind turbine industry being a really extraordinary industry at the moment, because all of the big players have very full order books and very big problems with profitability. And here, I think, is a way to add another function into a product at relatively low marginal cost, but very high value. So I'll leave it there. Thanks very much indeed, Jen.
Great. I will share my screen again here and so the point of kind of offering all these different perspectives, and I already see that there's questions being asked and kind of early conversations, and it seems that people are beginning to think. Well, one of the reasons that we wanted to show these different perspectives is that, of course, there's a challenge, and I see there's so many questions being asked and a level of different understandings as to certain assumptions. And so that's what we want this workshop to help kind of fine tune and gain some clarity on hybrid plants, which have so many different components and everyone has so many different thoughts and feelings. And so the goal of today's workshop will be to hopefully add some clarity and some guidance into the language that we can all hopefully agree on. Great. So with all that said, here are some kind of considerations as everyone's getting primed to enter into the kind of the subgroups, and I'll show a list of questions here in a second that will show the questions that we're going to be asking in the two different workshops. But as you can see here, as Seamus just mentioned, you know, generation integrated energy storage, something to consider, and also even kind of understanding how are hybrids and co-location even defined, or are they even included? It's as to what scope, and kind of thinking of the over 20 megawatt scale potentially within the gigawatt scale. And for this, we want to exclude virtual power plants as we feel they're essentially part of the grid. And the other thing also is that we would like to exclude microgrids, as this is in conflict with Task 41. So as we kind of shift here into the breakout groups, these will be your breakout group leads, and we'll provide for a few minute buffer for everyone to kind of get into the different rooms. And for breakout session 1, what we want to focus on is defining a hybrid. And so for this 45-minute breakout group, we will be focusing on these 5 questions and hoping that we can kind of define the parameters of a hybrid and terminology. So now I will pass the torch off to David to potentially give some instructions on how everyone can go into their respective rooms here.
That will happen automatically for the magic of Teams. And just let me know when you would like them to start. If now, that we can make that happen.
Thumbs up from my end if the other leads are also ready to go.
Fire away.
I think the rooms are being cleaned at the moment.
That's why I offered the buffer there. It looks like David is managing the rooms.
Managing might be a bit generous. Yeah, they were supposed to open and pull everybody in, so.
I see that my room is open, so I'm gonna go join, I think. No. Yeah, I'll go join my room.
Matt, apologies if I wasn't paying attention, but I'm not clear. Are the 3 breakout rooms in parallel? So we'll be splitting the cohort of the people present into 3, or are they in series?
This is Christian. I understand that there are 3 rooms, so it will be split up, but I'm not sure what happens to us here.
Yeah.
Because I don't see any room where I can go to.
Nor
Should
do
I
I.
find something?
Yeah, I apologize. There's supposed to be an automatic feature that pulls people into the rooms, and apparently that is not happening.
So could you, would it be better to send another link? Or no, something happens?
It's not the link, it's the meeting itself. So I'm going to give this another shot. The rooms are already established. So
Hi, David.
Uh-oh.
yeah, sorry. There were
All good?
We
I'm gonna
have
try
been
this
kicked
again.
out from
The rooms are opening up and it's supposed to automatically assign people to rooms. And apparently, I'm assuming that the only people who are in the rooms actually were Jen, Kaushik, and Chris.
No, actually, in our
Oops.
So, so David, really quick, I know that
Yeah.
Jen and Chris's room is open. I see that Kaushik's room is closed. And I think that's the only one that's left to open, but the other 2 rooms, I believe people are joining.
Okay. Sorry about this.
And David, it seems to be grabbing about half the folks. So folks that are remaining here in this meeting, if you can look towards the top of your window, there should be a little button that says rooms. It'll open up a side menu.
Yeah, I got it.
Oh,
Yeah.
okay. I'm just letting folks know if they don't automatically get pulled in, you can manually join the room that you've been assigned to. Just drop down the room number and you can join over there.
Awesome. Awesome. Yeah. I'm trying to manually open Kaushik's room and it is just going.
Sorry, where do we
Too close.
see the option of joining? Because I don't see anything.
Yep, me neither.
Yeah, it would
Sorry.
only be for people who are organizers.
Ah,
Yeah.
okay.
Shoot. Okay, I'm sorry, David. My bad.
No, that's fine. Okay. I'm going to remove Kaushik's room and then add it again because it keeps on going back to closed and I don't know why. I tested this yesterday and it was quite good. Should have tested it this morning and it would have been quite good.
But the 3rd group can stay in the main meeting room, maybe. Then we don't have to switch.
That's true. I'm gonna enter the room and just to let everyone else know in the respective room that Chris and I are in that we're having some delays.
David, if you could just get one of the moderators into this room, then we could start here as well.
Mhm.
Don't have to switch them.
Yeah,
around.
I
I'm
am
not sure
trying to
who's-
find Kaushik because his room was the one that
Okay.
for some reason was not behaving itself. Okay, I've messaged Kaushik. Okay, Kaushik is actually in a room that is functioning, so I apologize. I'm going to send you all to one of the rooms that seems to be working without any hitch. So again, my apologies for this.
So I'm not sure if that, I mean, there certainly are hybrids out there that are for a single consumer, and a good number of them.
Thought we had 2 minutes left.
It works.
Are we all back in the main room now?
Yes.
Yes, we're all slowly entering in. As everyone's slowly entering back in, Oscar, I had a quick question for you. I think this is an indication of how small the world is, but I think we've met.
I think so too, with Piotr, right?
Yes.
Yeah.
Yes. So yeah, with Piotr and Ellen as well.
Yeah,
Right.
exactly.
Yeah.
But do you still live in Boulder?
Yep, still in Boulder. Yeah, because I remember you came to CU for just a semester. Is that correct?
Yeah, that's true.
Right. Okay. I'm glad I wasn't going crazy and that I could have confirmed that. I wanted to mention that in our breakout room, but I guess we got booted out in time. So
Yeah, nice to meet you again.
yeah, you as well. It's been a while.
Yeah.
So in terms of kind of what we had planned, I know that we're not at capacity right now for this room. I know that when we started the meeting, there were way more people, so I'm not sure, but the initial plan was to take a 15-minute break and then circle back for 15 more minutes before we then transition into our second breakout group. And I see that there's more people joining, so I'll just reiterate one more time that what we'll do is we'll take about a 15-minute break right now, just for everyone to kind of reset, and then we'll have a 15-minute sync up again before we break out into the second group.
Thanks,
Awesome.
Matt. So we should be back here at 35.
Yes, so 35 in all of your respective time zones.
Thanks, Matt.
Absolutely. Hey, Seamus, can you hear?
Yes, indeed. Thank you, Matt.
Perfect. So it's a little after 35. I'll just sit tight for one more minute just in case. Okay. Hey everyone. I hope everyone had a great and productive and informative breakout session. Right now, for the next 15 minutes, what we will do is we will just have each subgroup lead just kind of give a summary of everything that was talked about and some kind of high-level themes and some key insights. So what we'll do is we'll start off first with the group that Chris led. So I have a slide prepared here for some of our summaries. So I will pass the torch up to Chris.
Yeah, thanks, Matt. So yeah, I think we had a pretty productive breakout session discussion. Thank you again for all the attendees for contributing. With regard to kind of the first question of what size of hybrid plant should be included, there was a range of answers across a range of situations. Some industries are looking at kind of larger utility scale. I think that was definitely agreed. There was an interesting point brought up about kind of island communities and hybrid plants there may not necessarily be, say, at the 20 or 50 megawatt level, but still providing a significant amount of power for that community. That could still be considered a hybrid system. So yeah, I think, as we think about designing these reference plants, we'll want to look at potentially a range of sizes systems and consider the situation in which those will be used in. On the topic of co-location, there was a lot of agreement here that from the grid perspective, the system should kind of, look as if it was one system more or less. So sharing a grid connection, having some sort of shared asset management strategy kind of behind the meter. The topic of ownership came up a little bit and whether that is required. Some folks thought, co-ownership could be a possibility. Others thought that, owning all the systems allows for that combined asset management strategy. And then there's regulation considerations. It seemed to be in certain situations, there might be a maximum distance that things could be spread apart. And then, of course, in other situations, say Spain, it was brought up that, for onshore wind, a lot of times the terrain's very difficult. It might be hard to physically co-locate another resource there, or it wouldn't make sense economically. And so there seemed to be a broad definition of co-location, but with consensus that the assets are managed in a similar way and perhaps share a connection to the grid. I think that's the grid perspective point there, yeah. So then the topic of black start came up as well. And it sounded like this came up in another session too. It was more a question towards the end. We didn't discuss it too much, but just wanted to bring it up here for the group to know about, if that's something that we want to consider in the operation of these hybrid systems. And then on the topic of cost savings, there seemed to be several avenues that the group thought, the cost savings could arise from. One being shared equipment, of course, just shared power electronics or shared electrical infrastructure, as well as the co-design of systems and looking at that complementarity that has been identified to be a strength of hybrid systems depending on what resources are available. And then the last one kind of being what type of services the hybrid plant might be able to offer, whether that's ancillary services or other services to the grid. This seemed to be kind of a way to result in cost savings, maybe through additional revenue or profit generation or maximization. So But overall, yeah, really good discussion. Went in depth on some of these topics a bit more, but I think that's a good overview.
Thanks, Chris. I will pass it off to Jen next.
Sure. I'm going to share my screen here. Sorry, I got a little lengthy on some of our answers, but we had a really great discussion on the what size of hybrid plants should be included. We thought maybe it would be best if we kept things grid connected. This makes it easy talking about transmission level rather than putting a number to it. There's different numbers for different countries. If we stick to the 20 megawatts that I had thrown out there earlier, a turbine could fill that in a few years here. So didn't want to put a number to it per se. Keeping on the transmission level seems to be a good deciding point. What does co-located mean here? Piggybacking off of what Chris said and things like that, we're talking about a single interconnection point, but it's not sufficient per se. We do think that there also needs to be a common point of control, but it doesn't necessarily need to be the same owner. There are examples in our group of where there are hybrid plants that exist that aren't the same owner, but there are common control and a common interconnection point. How are microgrids different from hybrid power plants? Short and sweet here, put microgrid as a group of consumers, hybrid power plant as a group of producers. It doesn't fit exactly perfectly, but conceptually, that's kind of how we thought about it, where a hybrid power plant really serves kind of one end use, maybe a few. Opportunities for cost savings in the hybrid power plant area, shared everything, basically, even including the interconnection point and including complementarity of resources. Installation timelines was brought up, which I think was really cool. Cross-training and O&M, meaning workforce development. If you train a workforce to do wind solar storage, that makes things a little bit easier, and direct coupling of technologies. And then finally, to the types of services that hybrid plants would be asked to do, a range as expected. Energy market grid services. Blackstar was also brought up in our group as well, being that there's a battery in the system or some sort of storage in the system, power to gas. And really, this will be defined based on the value to owners, which is kind of what Kaushik brought up really early on. So that's kind of the results from our breakout group and the direction our discussion headed. So with that, I'll turn it back over to you, Matt.
Thanks, Jen.
Anything that I missed, Dan? Sorry, I should have consulted my counterpart.
No, I think you got a good summary.
Thank you.
Awesome, thanks. And then just lastly, Kaushik.
Sorry, I was muted. Did not realize, but I'll share the screen. We had very interesting discussion, and what we discussed, or rather agreed, all of us in our breakout room. Can you see my screen, Matt? Yeah.
Yes.
So we rather decided in the group or discussed that it might be better to rather agree on defining a taxonomy which is globally acceptable. So because the hybrid word is very much used in all different contexts, so rather define a whole range of situations or whole range of type of plants or systems, and then probably make different branches of them, including all possible variations like different kind of generations plus, or generation plus storage plus generation plus energy conversion, or any of those mixtures. And then rather focusing on what is the scope of IEA Wind Task 50 on that taxonomy, instead of deciding how we the scale or the co-location of the hybrid power plant. We also discussed that should we only focus on on-grid or off-grid, but we also understand that there are many plants around the world which are coming up as off-grid or more so in future, but they are still on large scale. I think Asma gave an example of 300 megawatt in Australia of off-grid. application. So we did discuss about two of the most important keywords which we discussed, but we did not get the time to discuss all of them. One is co-location, as it was there in the agenda. So one thing was behind the single substation, or it can be same point of connection or same point of common coupling. But there were also discussion that if maybe then we should consider the metering that it can be behind the meter or front of the meter, depending on how you see it, co-location. But maybe more important point of a hybrid plant is not co-location. It is co-location, but also the cooperation or management of these assets together. So, and this again went back to the discussion on the taxonomy, that when we discuss the taxonomies, then we can have a co-located plant or co-located system and co-located or grid connected off-grid system, smaller system, larger system, islanded systems, and things like that. So then we can scope what is the scope, what is in the scope of task 50. We did not get much time to discuss on the cost saving / value maximization, but we agreed on that maybe as the next step that we need to discuss on the functionalities or the purpose, like a hybrid plant is something which is fit for purpose, like peak plants or something like that. So it is more rather defining what is the utilization, why do we need hybrid, what is it used for. In terms of microgrid versus hybrid, I mean, we all of us agreed microgrid is very small. I mean, I think Florin had a comment that it is less than 1 kV is microgrid generally. So by the name, it's microgrid very small, and the challenges are very different. So we did not discuss much on the similarities, dissimilarities. I'm sure we'll get much more opportunities in the future to look into it. But if I know I have not covered everything from my notes in this quick notice, but anyone from our breakout session, if there is anything more to add, please provide your feedback. Otherwise, over to you, Matt.
Awesome. Thank you, Kaushik. Okay, so I will resume here to share my screen again. So now what we're going to do is we're going to pivot into the second breakout group. And so for this second breakout group, we are going to be talking about technologies. What technologies are we looking at? And something that I wanted to add is that the takeaways from this breakout group will help inform our reference designs for work package 2 in January, one of which does have a hydrogen component. And so we will have 2 to 3 different reference designs that are led by Dominic at TU Delft. And another talking point also, speaking of January work packages, we will also have work package 3 and 4 meetings in January as well. So if you can just keep your eyes peeled on your inbox for invites for that as well. Okay, so I guess now I will ask David here if we can kind of get back into our breakout groups. I know that there is going to be a minor reshuffling just so that we can have adequate numbers in all 3 breakout groups equally. So some of you may or may not find yourself in a different group this time.
Yes, as it is appropriate for your different faith traditions, please light a candle so that this works more smoothly. Here we go.
Thanks, David and Matt.
So Kaushik, really quickly, just finishing up the last sentence. I think it's maturity and interest, and IEA is very unique in the sense that it helps lead the world in what the world should be thinking about. So if there is an area that is of interest to the world, like hydrogen, then IEA should definitely be looking at it and providing guidance to the world on the viability or under what conditions different options are should be considered.
Thanks.
Sorry, everybody.
Yeah.
That was a beautiful note to come back on, Ian.
Thanks, you're generous.
Hey everyone. So it seems that I think we're all coming back to this room. And so I think everyone's going to be tuning back in here. As everyone's kind of rejoining, I think what we'll do is we'll just take quick 5 just so that the note takers and the subgroup leads can kind of process and just kind of do the same thing where we take a high level slide to summarize some interesting takeaways. So 5 minutes, so then we can be back, let's say, a little bit before something 40, so everyone's respective time zone. So if that works for everyone, then great.
Sounds good, thanks.
Thanks, Matt.
Yep. Okay, hey everyone. I'd say it's been about 5 minutes or so. So as everyone's kind of fitting back in, Chris will start off from our subgroup to give an update. So I'll just pass the torch to him.
Yeah, thanks, Matt. So again, yeah, we had a pretty in-depth conversation about these questions. So thank you again for our participants for providing their feedback. With regard to kind of what type of services should hybrid plants provide, we got a long list. I think longer than we can list on the slide. It didn't seem to be that there was any opposition to a specific service, but a lot of grid-focused services, ancillary services. People talking about resiliency and system protection as kind of key areas as well. And so I think that for hybrid power in particular, being able to provide these type of services is definitely a topic of interest and will be something we want to consider. What type of end uses should be considered? Excuse me. The topic was brought up if we kind of limit ourselves to transmission or grid connected type services or type plants. Sorry, the end use obviously electricity production and then these other grid services. But if we kind of branch outside of that, things like H2 production, ammonia, direct connection to specific industries, say manufacturing or that sort of thing, become possibility. Also, the topic of resilience came up here too. So, that the hybrid power plants being able to provide different types of capabilities in maybe emergency situations, that sort of thing, or being able to ride through different situations would be really useful. So we don't have a bullet point on here, but we did discuss the kind of storage types. Some of the obvious ones that came up were batteries and then electrolyzers converting to H2. But hydropower is one that was also brought up as an option. That was something I think Seamus talked about in his initial perspectives. There was also the thought that we don't need to limit ourselves to mechanical storage. So thermal storage or solar thermal being an option, molten salt. And so yeah, again, maybe there wasn't any one technology or storage type that we shouldn't include, but more looking at the different types and of course the big ones being batteries and H2. Pardon me, I'm just a little groggy this morning. And then kind of jumping down to the bottom in terms of terminology and consensus about this, we had a good point brought up that maybe definitely a need for a common terminology or an ontology when discussing hybrid plants. I think that was a topic that Kaushik's group brought up at the end of breakout 1, but specifically looking at perhaps kind of two subtypes of on-grid hybrid power plants and end-use hybrid power plants as being kind of a division that would be useful and to build terminology out around and to be able to kind of specify between. So a lot of thoughts there. The notes have a lot more details, but again, this is just kind of an overview from our group.
Thanks, Chris, for that. Yep, so now I'll just pass it off to Jen again, and we'll just follow the same order as last time.
Great, thank you, Matt. Okay, so our group, adding on to what Chris said, so trying to add in we have a long list of notes as well. Types of end uses that should be considered. Electricity is the main one, especially because our group had been considering on-grid hybrids mostly for this task to focus on. Hydrogen being an end use, but electricity would be the primary use. It doesn't necessarily mean that it needs to produce more electricity than hydrogen. Very huge question mark there, but just so that it's built for grid connection. Types of storage to include. I don't have the types of storage per se here, just a few notes to consider. The types of storage are in the notes. Consider duration. Can we have multiple types in one plant to service different timescales rather than one storage technology trying to service multiple timescales? Synchronous condensers potentially to help from an inertia perspective, and is there some opportunity to co-locate and repurpose existing infrastructure such as coal to storage on a variety of durations? technology combinations I put in here as here's our top 3 from the group. Wind, solar, storage. I look like that was tied for, or that was similar with your group, Chris and Matt. But also wind, wave, and storage offshore specifically was right up there in terms of we had a tie there, and then wind, hydrogen. And the last thing I want to put here is policy considerations really drive the design discussion here. So different markets might require different things, like you might need to track where electricity originates, and so that might drive how you use your storage. There might be restrictions and overbuilding based on cybersecurity concerns. Some markets might have first take rules for renewables. If that extends to batteries, that's going to drive your operation as well. Is there a best metric? We talked about, rather than LCOE, moving towards this cost of valued energy that has been circling around. Interconnection queues also drive what you can build, the value in terms of how fast we can decarbonize, and grid congestion. So I just wanted to call those out separately because those are really going to be driving factors in our work. Of course, the policy and markets are going to be different across the globe, but maybe there are some core pieces like decarbonization value or something along those lines, or grid congestion that we can zero in on for those. Back to you, Matt. Actually, quick, I keep forgetting. Dan, is there anything else that I didn't cover?
No, I think that was a good summary. I think maybe the biggest question we came back to a couple times was for our scoping and definitions. Is it a hybrid power plant, a power plant that sometimes does something else, like making hydrogen or whatever other product, or could it be a plant that primarily makes something and sometimes provides electricity? I think that balance was undecided.
Thank you.
Great, thank you so much. All right, and then last but certainly not least, Kaushik.
Sure, Matt. I'll share this. Yeah, we also had very nice discussion in our breakout room. So we started with discussing what kind of services, and it was clear that the services generally vary from country to country, and also types of technologies there in the plant. So the both the capability and the requirement vary from the use case purposes, and then it depends on the purpose of design or value proposition for each plant. So that why we need hybrid as compared to individual technology plants. So again, there is always a value, and that would define the services. But generally, we saw some of those like categories which can capture. One is the energy production is the simplest one, no-brainer, and then energy capacity, operating reserves, all kind of frequency reserves, balancing reserves, regulation markets, whatnot, power quality, including voltage, reactive power, harmonics and things. Black start is something which requires a special shifting of modes, but also special requirements to provide, so that we try to keep that separately from the reserves and the power quality. And then power oscillation damping is also something which we are seeing more and more coming up requirement today. So, but we should also make decided that we should keep the scopes rather broad than considering the future opportunities, and not only consider the because the services are both from grid code requirements or regulation requirements, as well as market services. So we don't know how the future market would look like, how those requirements, which one would be grid code and which one would be market. So rather than defining based on how it is today, we should rather keep the scopes open for future. Moving on to the use cases, then we discussed that electricity production is the starting one, but power to X production, be it hydrogen or some other gas, methane, methanol, ammonia, any of them. it can be of use case for future hybrid power plants, and thermal energy is another thing which we are seeing quite a lot in the smaller scale, but maybe in future it would be of use for generating heat, at least in this part of the world we see, or the northern part of the world where there is quite some requirement of heat. And same goes with the fit for purpose this goes to the previous comment that purpose of design and value proposition. So use cases will be like in India, we are seeing that peak or base load around the clock plants are coming up, and so more and more so similar use cases would come in future. And then maybe carbon capture is something which can be of interest for future as well. Depending on the types of storage, so we thought that it's better to categorize them in terms of the time scale as well as capacity. So when we say capacity is both power and energy capacity, and then the division between power and energy, how much is the power density and energy density depends on the use case as it is there. And this is something we can probably discuss more with Seamus and others in the storage TCP and other storage groups, that how to differentiate the time scales. What does it mean very short, and medium and long term? What are the definitions? And then we can include them in the use cases. Storage to meet the energy production use case. That's also another thing. Not only the services, but the hybrids are also need to provide some energy production as the starting point, and that storage it depends on which type of storage is required depending on the energy production use case as well. Hydrogen, there was a question whether hydrogen should be considered as a storage. So we again kept it open that hydrogen can either be a chemical storage or as a product depending on the use case, because it depends on the use case whether you will have that flexibility to use hydrogen as a storage, or you need to keep on producing hydrogen for the business case. In terms of priority of technologies, we really did not get much time to discuss on this, but we assume we had some discussions that both maturity and interest should be considered for prioritizing the technologies. For example, was it carbon capture, maybe of interest, but it is not that matured to be considered. But then hydrogen, it is getting matured as we speak, and it's also of high interest. And this is what Ian and I were discussing when we just moved into this the main room. Maybe Ian, you would like to add something, because maybe I have not just done the justice to this bullet what you were mentioning.
No, I think you captured it.
Okay, good. So that's all. Matt, over to you.
Great, thank you so much. Ready, let me just get my screen shared here. Okay, so first and foremost, thank you everyone for giving us 3 hours of your day. I know that 3 hours is a lot, and everyone's very busy, so we're really grateful and appreciate everyone's insight for today. In terms of next steps, what has to happen is the Task 50 group is going to be kind of processing all the notes, making sense of everything, identifying themes, and with the hopes that we can then reach a consensus on terminology and whatnot. And so there's that component, and then also there are 2 deliverables that will be coming out of this, and that is a journal paper and a report. The report is going to be a report out from the findings of this workshop, and so right now we are open to seeing if anyone within this workshop wants to help participate in that. That could be a great opportunity to collaborate as well. And if you have any questions or would like to follow up in terms of participation for either the journal or the report, my email is here, and you are more than happy to ping me an email just to kind of start the conversation there. And then the last thing I will add is please keep your eyes peeled for any follow-up emails in regard to work package 1. So yeah, and then I'll just open up the floor to the rest of the team, and as well as anyone else if they have any anything else they'd like to mention.
The only quick thing I would like to add on top of that, Matt, thank you for the summary, is that the journal paper will be in collaboration with IEA Task 41 on microgrids, specifically addressing differences between utility scale hybrids and microgrids, which we've talked a lot about today. So there will be differences between the report out and the journal. And let Matt know if you want to be a part of one or both.
And keep your eyes open for the other work package invitations, which we plan to have it in January after the holidays.
Great. Well, if anyone has any last minute questions, comments, I can stay on the line for a few minutes. Otherwise, thank you so much to everyone that's joined and participated. The insight is very valuable, and most certainly looking forward to kind of filtering through all the notes and to get some more guidance and clarity. So thank you, everyone.